Thank you for this. Thank you for this good afternoon. I pray that we have a peaceful and understanding lesson with the teacher. I pray that we understand everything we're going to learn and everything goes well. In Jesus' name I've prayed. Amen.
Okay, thank you so much, Ethan, for the word of prayer. Good afternoon, everyone. Let me hope you are having a good afternoon. Today, we are going to be looking at this topic. When you look at the picture I have started with, oh, sorry, I'm going to I'm going to display the picture again. I'm going to display the picture again. But those who have seen the picture, feel free to raise up your hand and then you can share with us probably where you have seen that, where you have ever seen that area, or whether you have seen it or you have never seen it somewhere. But in case you have seen it somewhere, feel free to share with us.
Mine is in a meandering road.
Okay, I'm going to share my screen again, and then you can share with us where you think this picture was taken from, or which district you think this picture. Yeah. So I've shared the screen in case you have, yeah, anyone who could be knowing where this picture, which country, which district, or any of you who has ever been this side. Okay. Yes, Galax. Galax, you can unmute.
Kabale in the Western Uganda.
Okay. In the Western Uganda, Kabale. Okay. That is true. True. Those who have been those ends of Kabale, I know you might have seen something like that. Okay. Thank you. Zawi.
Kabale.
Galaxy.
Okay. Also, Zawi is saying Kabale. Okay. Okay. Fine. Fine. So, when you look at this picture, it is from those ends. So, another picture. Okay. Now, when you look at my screen, you are seeing some simulations. But what do I want you to look out for? I want you to observe the speed. When you look at this is our skater here, and I know some of you enjoy this game here, but I want you to check out on the speed. Look out for this instrument here that is measuring the speed, and also you'll tell me what you have observed. So we are going to start our journey. So I'll ask you to observe. Okay, I'm going to put it now in the slow mode. I'm going to put it in the slow mode. Observe the speed. Okay, so I'm going to put here A. I'm going to put here B, and I'm going to put here C. Feel free to raise up your hand and you tell us what you have observed on the speed at the different points. Feel free. Okay. Yes. Okay. Yes, Moga.
What I'm observing is that as the skater comes from point A to point B, the speed increases, and when he's going to point C, the speed slows down.
Okay. Thank you. Galax. Okay. Nico.
Naitwe. What I've realized is at point A, once he's going from point A to point B, he increases his speed. At point B, his speed reduces. Then from point B to point C, speed decreases.
Okay. Thank you. Tony. Oh, Tony.
Kwanya mimi wayami wazina
Okay. Lastly, Zion and Paul.
Good afternoon.
Yes, good afternoon.
What I observe is that when the skater goes from point A to point B, the speed increases, and as they go up to point C, the speed reduces, and vice versa.
Okay, thank you. Let me put another one and then you look and see what is happening. Sing, anyone who wants to share what you have observed? You can look at the speed, the way the gentleman is enjoying. Anyone who wants to share what you are observing? Okay. Just give me a minute. Okay. 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 Yes, Venus? Okay, now what are we going to look at? I wanted you to observe this and I tell you what we are going to look at today. So for our session today, our major area of focus is going to be around that area, what you have been able to see. What you have been able to see, we are looking at the different positions at which the speed was changing. So the speed was changing depending on the different positions where that person is. Whenever you are traveling, when you look at my screen, like people have told us that this is covered. And one of the most difficult areas to navigate is this area here. If you are not, sorry. Okay, sorry about that. Now, this area here is one of the areas whereby if at all you have not been there before, it always needs that you drive at a very slow speed. But what idea are we trying to bring out? That whenever you are traveling, the speed at which you move at keeps on changing. So when someone is here, you'll find that the speed is different. When it comes here, it is different. When it comes here, it is different. Here, it is different. Here, it is different. Here, it is different. Like it keeps on what? It keeps on changing. And whenever you are traveling these ends, always you have to warn your parent, like you tell them, mommy, you got a very slow speed because any mistake that maybe they make, God forbid they does, you'll find them that you can fall deep this side and rare, and it may be hard for you to be able to survive. But what are we going to look at? We are going to look at how does the distance, the time, and the speed change over time. So last time we started on our topic on linear motion. And under linear motion, what are we going to look at today? So today we are mainly going to focus on one thing. We are going to focus on what we call the average speed. And when we talk about speed, we are looking at the distance, we are looking at the time, and we are looking at how do those things change over time. So that is what we are going to mainly look out for today during our session. So we are going to look at what we call average speed. And when we talk about average speed, we are looking at the total distance you cover divided by the total time that you do take. Here you look at, let me give you an example. You have started from Kampala, you went to Jinja, from Jinja, you went to Yiganga. From Yiganga, you went to, what is the next district there? Yiganga, you go to, okay, let me say you have gone to Malaba. Let me say this is 75 kilometers, this is 80 kilometers, and maybe this is 90. Now, when we talk about the average speed you have covered for the motion, we are looking at what is that total distance you have covered. The total distance means that now you are going to all get this distance you have covered from Kampala to Jinja, add it on this distance you have covered from Jinja to Yiganga, add on onto this distance you have covered from Yiganga to Mbale. So, or to Malaba. Now that is the total distance. Then when we talk about the time taken, we count that from Kampala to Jinja, how many hours did you take? That maybe the person used 1 hour. From Jinja to Yiganga, how many hours? Maybe 0.5 hours, a half an hour. Then what about from Yiganga to Maraba? How many hours did you use? That maybe the person used 2 hours. That means that the total time for your journey is going to be 1 hour plus the a half an hour plus the 2 hours. And now that one will formulate what we call the total time taken for your journey. So that's how we obtain the average speed. We get the total distance you have covered, divide by the total time taken for the motion. So can I ask you to summarize something in your book, and then we start looking at some calculations? So take note of something. When you finish, let me know through the chat such that we can now continue. Okay. Okay. People have finished. People have finished. So we are going to start on the first activity here. Now, whenever you are given an activity, the first thing you do is that first identify some of the key terms within that activity. Now, they have told us that Angel travels the distance of 40 kilometers in 3 hours. Now, what have they given us? They have given us our distance, and the distance the person has covered is 42 kilometers in 3 hours and 26 kilometers in 2 hours. Find the average speed. Always first come up with a formula. So we shall say that average speed will equal to the total distance covered by Angel divided by the total time taken. Now, when you look at our question, what is the distance this person has covered? She has covered 42 and then the 26. So we shall come here and say 42 plus the 26 divided by the time. So for the 42 kilometers, she used 3 hours plus for the 26 kilometers, she used 2 hours. So here I will put 2. Then after we add 42 plus our 26. So you add 42 plus 26, you end up with 68. And then after we shall say 3 plus 2, which will give us our 5. Then after you divide, you say now 68 divided by 5, what do you get? You end up with 13.6. Now, always, the moment you are dealing with physics, it is always important you write the units. Now, when you look at our distance was given in kilometers. That means that here we are going to have kilometers. And then our time is given in hours. So this is out of the hours. That means that when you are writing your average speed, we shall write it as kilometer per hour. But in some books, you can find them writing kilometer then per hour. So that is what we have as our speed. May I know whether everything is okay to everyone? Is that okay? You are finding some challenge? Feel free to raise up the hand. Okay, okay. Peter says it is okay. Hope the rest, it is so from the chat, members are saying it is okay. I think I'm going to move on to the next screen. I'm going to move on to the second screen. And I'm going now to invite you to first summarize, and then you first try it on your own. We are going to first try it, use the same formula. Use the same formula, but first Okay, I'm going to take an assumption that people have been able to finish. So people are saying 26, the others are saying 22, others are saying 9. Okay, we are going to try it. Namukose?
I wanted to say that I got 9.
Okay, Namukose, could you take us through how you got there?
I said average speed is equal to total distance covered
Okay,
out of total time taken.
out of the total time taken. Okay, good.
So 20 kilometers.
20
20
kilometers.
kilometers plus 25 kilometers divide by
Mhm.
2 hours plus 3 hours.
Okay.
So I got 45 divided by 5.
45 divided by 5.
And I got 9 kilometers per hour.
Okay, 9 kilometers per hour. Okay, okay, okay. Thank you. Members, we are going to respond. We are going to check out. NN.
Yes, sir.
Yes, how have you approached it?
I said average speed is equal to total distance over total time. I added 20 plus 25 over 2 plus 3, which gave me 45 over 5, which gave me 9 kilometers per hour as my answer.
Okay, can I first ask? What do you think 20 kilometers per hour represent? Okay.
Pardon?
What do you think 20 kilometers per hour represents?
I think that 20 kilometers per hour represents the only kilometers taken. Let's say that it is the 20 kilometers. That means the 20 kilometers were taken in only the first hour, and therefore they said the bus travels the first 3 hours of the journey with a speed of 20 kilometers. That means the first hour was they covered only 20 kilometers. That means this person who has said 20 plus 25 never covered the other 2 hours. That therefore we have to say total distance taken divided by total time. We first get the first the kilometers covered in the first 3 hours. We say 20 kilometers times 3 hours, which will give us 60 kilometers. After that, we go here to the second kilometers. We say 25 kilometers times 2, which will give us 50. We add the total distance, which will be 60 kilometers plus 50 kilometers, divide by the 3 hours plus the 2 hours, since it was the total time, which you will get 110 kilometers, divide by 5, where you get 22 kilometers per hour. That's what I think.
Okay, okay. Thank you, thank you, thank you. Now, members, I want to bring it to your attention that always first go through the item. The people who have given us, this was very okay. This was very, very fine. But now, what did we notice is that they told that a bus travels the first 3 hours of the journey with this speed, and the next 2 hours of the journey with this speed. Find its average speed. Now, what do you have to know? One is that here they have not given you the distance. Whenever you find kilometers per hour, like even they have told you here. For the heat. the moment you notice that this is the speed, it means that for you to get average speed, we have said, you must have the total distance, you must have the time. The good thing is that we have the time, the 3 hours and the 2 hours. So members, your total time you have given us, which was 5, was very correct. The only thing that we did not get right was our distance. Because the distance they did not give us the distance, but they gave us the speed, meaning that what are you going to do? You are going to first find what is the distance. We know very well that distance is given by our speed, then times the time. So you are going to first find out when the bus travels for the first 3 hours with this speed, what distance did it cover? So that means you will say 20 times 3, which will give you 60 kilometers. That means that after 1 hour, this bus covered 20 kilometers. 20 kilometers per hour means that like whenever an hour passes, the bus would have covered a distance of 20 kilometers. Now, members, you tell me, 25 kilometers per hour. If the bus traveled for 2 hours, in the chat quickly, tell me, if for every 1 hour the bus covers 25 kilometers, in 2 hours, what distance would the bus have covered? What distance? Put there. In 1 hour, the bus covers 25 kilometers. What about in 2 hours? Perfect. In 2 hours, 50 kilometers. So that means that you will say now distance is still speed times your time. Now your speed is the 25 kilometers, then times your time, which is 2, which gives you 50 kilometers. Now, what do you have? You have the distances that this bus has covered. That means that now you are in position to obtain your speed. So we shall come back and say that what is the total distance? We shall say now 60 plus 50 divide by the total time. The bus took 3 hours and then 2 hours. So divide by 3 plus 2. So, I think members are not seeing where they went wrong. So this will be 110 divided by 5. And what are we going to end up with? 110 divided by 5, we shall end up with 22. But now, since they asked for average speed we said means distance out of the time. So this will be kilometer per hour. Members, is that fine? Kindly let me know through the chat. Is that okay to everyone? Okay. People are saying yeah. Okay. Now I think we are going to continue. Yes, always read through such that at least you know that you are on track. Okay, let me see whether I have another one here. Recording in progress. So can you summarize? I've asked you to summarize. And when we talk about average speed, speed is a scalar quantity. So its direction it takes does not matter. Its direction does not what? Does not matter. What only matters is the scalar. So its direction does not matter. So we always consider the magnitude. Okay, so first take note. I want you to summarize, make your own notes of something you want from that slide. Something small from that slide. Okay, when you finish, you can let me know and then we'll continue. You can let me know and then we continue. But I'm going to allow me to give you at least one more such that we check our understanding, So this is our number that I want you to try out. So I'm going to say, says A, B, and C are 3 points lying in the order on a straight road with A to B equaling to 5 kilometers and B to C equaling to 4 kilometers. Then it goes, a man runs from A to B at 20 kilometer per hour and then walks from B to C at 80 kilometer per hour. Then the part A, find the total time taken to travel from A to C. Part B, the average speed of the man for the journey from A to C. So that is the thing. So can we first try it as well on our own? We are going to try it on our own, and then after we shall discuss the answers we shall have come up with. So remember now you need to think as what do they want? That now they want the time. Okay, can we So even feel free to even come up, for you can even first make a line and say, this is my line. This is A. This is my point B. This is my point maybe C. You can do like that, such that now you know what you are going to do. You say, this is my point B and this is C. And then you say that from A to B is 5 kilometers. From B to C, the man was walking. So first find out, from A to B, what speed was he using? They told that a man runs from A to B at 20 kilometers per hour. So here, he used 20 kilometers per hour. Now, what do you need? You need to find out the time. So can we first to tell you that record progress. I'm going to look through the chat and see whether people have been able to calculate. According to the chat, some people are getting 12 hours, others are getting 13, 0.75. Good, good. Sema, what are you getting? Romans? Okay. Yeah, okay. Nancy, you can tell us what you have.
I've not yet finished getting my answer.
Okay, but you can tell us what have you got for A to B, or how do you do A to B?
A to B. Okay, what I'm using is total time is equals, okay, time is equals to distance divided by speed.
Time is distance divided by speed.
Divided
So
by
what is the distance? A to B?
5 kilometers, and the speed is 20 kilometers.
Okay. And what do
Yeah,
you
but
end up
I was
with?
going to add both. I was going to add the speed also.
Okay. Now remember, here you have two
Let me,
different components. So before you add them, first obtain from A to B. Then after
yeah.
you obtain from B to C. Are you getting it? Then that's when now you can go on and add the time. Okay. So here, when you place on your calculators, you'll get 0.25 hours. Okay? Samsung, B to C. Oh, I'm failing to get Samsung. Isadora.
From B to C, I got distance out of speed was 4 kilometers out of 8 kilometers per hour, and then I got 0.5 hours.
0.5 hours. Okay, can you
When I
continue and now tell us?
when I
So
added
what is
them, I
going to
got
be?
3 hours.
You got
0.3 hours.
0 point.
3 hours.
Oh, you got 3 hours. Sure.
Zero
Add for us
point.
what?
Okay. Oh yeah. Sorry. I done it wrongly.
Okay, but now we can collect and tell us what you get. Did we lose you? Okay, the cruise. Oh, I'm failing to get the cruise. Yes, the cruise.
I was kindly requesting. I've not understood any of these. The way the question approach.
Okay, did you get,
That is,
like they told us, you look here, they told us that we have a load and we have 3 points. Like you can hear, you can say that this is like Mukono, this is Lugazi, and this is Jinja. And like from Mukono to Lugazi is 5 kilometers. From Lugazi to this is 4 kilometers. But they are telling you that when this gentleman was moving from one town to another, the speed he was using, he used 20 kilometers per hour. So here, the speed was 20 kilometers per hour. Then when he reached this town, from this town to the other one, he reduced the speed. So, and here they told us the speed was 8 kilometers per hour. And
Hour.
now so they're asking, what is the total time this person took to move from A to C? Now, in order for you to get the total time, you need to ask yourself, from A to B, how many hours did he take? And then from B to C, how many hours did he take? Such that for you to get the hours from A to C, you add the hours used to move from A to B, and then the hours used to move from B to C. Is that
Teacher.
fine? Yes.
Yes. Ma'am, asking, can hours be expressed in 0 point like that, or we have to just change them to minutes? Can they be expressed in 0 points, in decimal points?
Yes.
Hours.
Yes, hours they can. And even here you can give it in fraction form. Remember, the standard units for hours are seconds. So if you are converting them from here, then you can convert them into seconds. Are you
Okay,
getting
thank
it?
you.
And
Yes.
since the question was talking about hours, then you can give it in hours. So this is, or in fraction, this is 3/4 hours. 3/4 hours. Okay. Ellie?
Teacher, I was going to give the total time and the average speed.
Okay. Can we take us to the average speed?
The average speed, I use the formula of total distance covered divided by total time taken.
Okay. Total distance divided by total time. But members, you write in words. So what is our total distance?
I got 5 kilometers plus 4 kilometers divided by the total time, which is 0.75 hours.
Okay.
And I got 9 out of 0.75. And my answer was 12 kilometers per hour.
Okay, 12 kilometer per hour. Okay, thank you, Ellen. Members, let me hope that is okay. I'm seeing in the chat, members, we are getting there, 45 minutes, a quarter hours. Okay, very good. In case you have a question, please go on and ask before we go on. Swabi Banks? Swabi Banks? Swabi? Okay, I've failed to get Swabi. Yes, Swabi? Swabi? Okay, okay. So we are going to continue. We are going to continue. Yes. Let me know through the chat whether you need another number in the same caliber, or or you people have understood. In case you need another number, you said give us that one more number in that caliber, or let's continue. You can let me know through the chat, and then we see what to do. So if you want here, someone, because remember you are pointing in time, it is okay for you to say 45 minutes. I'm looking through the chat. One more. Okay, one more. Okay. Let me clean here still, and I give you one more in the same caliber, such that members can try out. But learn to read to understand. Okay, I have another one here. I'm going to still use A, B, and C at 3 points, but this one I think we can do it as our homework, members. I'd suggest, or I propose. In that order, you are going to do it as part of your homework, but you write it on a straight load with A to B equaling to 40 kilometers and B to C equaling to 90 kilometers. A woman travels from A to B at 10 kilometer per hour, and then from B to C at 15 kilometers per hour. Calculate part A, the time, the total time taken to travel from A to C. Then part B, the average speed. The average speed of the woman for the journey from A to C. Okay, yeah. So this is going to be a part of your homework that you'll do. So just write it down, and then we shall try it in our free time, or after the call. You try it and then you check out whether you have understood. Okay, you let me know that you have finished, and then Joy has already got the answer. Okay. Okay, okay. Are we going to continue? Finished, eh? Okay. Let me wait for more two people to let us know whether they are finished, and then we proceed. Okay, good. Okay, so that's how you can attempt search. Okay, we are going to continue. Now, we are going to look at another concept in the same caliber. And which concept are we going to look out for? We are going to look at what we call velocity. When we talk about speed, we are looking at the distance you move at a given time. That is distance. When we talk about velocity, velocity is also speed. However, the difference between velocity and speed is that velocity, you take into consideration the direction. Are you moving towards the east? Are you going to the west? So here we consider the direction. So when we talk about velocity, we are looking at that displacement. We are looking at that rate of change of distance in a given direction. So when you look at my screen, you are noticing that I have what we call speed. So speed is talking about how fast are you traveling. And then velocity is speed in a given direction. So speed, you are just looking how fast are you traveling. But if you look at the direction you are taking, is the direction safe? Which direction are you going? Are you going up? Are you going down? That's what you call velocity. So here you look into the direction thing. And what is velocity? Yes, like I've told you that velocity means the rate of change of displacement with time. Displacement is the distance you move in a given direction. That is displacement. Displacement is just distance you have covered, but in a particular direction. So the rate at which that distance changes with time is what we call velocity. And how do we obtain velocity? Velocity is displacement out of the time. But we know that in physics, we have what we call SI units. Now, displacement being distance is measured in meters. Then time, the standard units for time are seconds. So that means that our units are going to be meters per second, or mathematically meters per second. And that's what we call velocity. So may I ask you to write, but in case you have a question, kindly ask. Okay, let me first pick a hand from Eileen.
So my question is, why is velocity measured in meters per second while in the average speed we're using like kilometer per hour?
Hey, why is velocity? Now, velocity, okay, we have what we call fundamental quantities, right? Have you heard about fundamental quantities?
Yes, teacher.
What are they?
Fundamental quantities. Teacher, I've forgotten.
Okay, we have mass, length, and time. Those are the fundamental ones, eh? Mass, length, and
Yes.
time. Then you can add on others, eh? Now, both units are correct. Even the speed you are talking about can as well be measured in meters per second. But speed is measuring a scalar quantity, and velocity is measuring a vector quantity. Now, meters per second and kilometers per hour are the same units. All are units of measurement for speed and for velocity. But the only difference, or why here we mainly consider meters per second, is that velocity, we are looking at major quantities. We are looking at those quantities that are measured. So always we consider the standard units. So the standard units for measurement of these things are meters per second, or meters. Like whenever you are going to measure the distance in physics, the standard units for length, when you are measuring any length of any item, the standard units are meters. And in case you are measuring time, the standard units are second. Now, other units that come in, those are minor units. So kilometers, hours, those are the minor units. But the major units we use for measuring length are meters, and time are seconds. So velocity being a major quantity, that's why for it we use the major units, or we write it in a standard form. But you can as
Thank
well
you,
find the
teacher.
speed. You can find the speed depending on the book you are reading. You may find them when they have used meters per second. It is very okay. But in real life, when we are measuring speed, because speed is a bit very fast there, so you'll find that they use mainly kilometers per hour. But it does not mean that also they are not units. You'll find when they are using meters per second for speed as well.
Thank you, teacher.
Okay. So, members, are we good to continue? Are we good to continue? Okay. M copper. Okay. Yes, M copper.
Excuse me, teacher.
Yes.
Good afternoon, teacher.
Yes, good afternoon.
Good afternoon. You mean that
Yes.
the reason to why we use kilometers when measuring speed, it's because that it is faster.
Not like it is faster, but like it
Yes.
is a major, when you are, let me say, meters is a small thing. So you may find that in case you are reporting to someone, you'll find that you'll say 1,000 meters per thing, of which 1,000 meters per something is some. So someone would rather say 1 kilometer
It is
instead of saying 1,000
1
meters.
kilometer. So, okay. Thank you, teacher.
Okay. Yeah. Meters are small things, eh? A meter is small. A kilometer is big. So we are trying to make it a bit smaller. But otherwise, just imagine you are going to Mubende. Okay, Guru. And someone asks you, what distance are you going? Or what displacement? Or what distance you are going to cover? And then you tell the person, I'm going to cover 400,000 meters. Someone will say, that's a lot. Yet actually when you use kilometers, you say that from Kampala to Gulu is around 400 kilometers. So it is a bit much easier, even in communication. Now, we have what we call uniform motion and what we call non-uniform motion. When we talk about uniform motion, uniform, the way you had the word uniform, uniform means like something like, okay, let me use this, that this is 0, 1, 2, 3, 4. For something to be uniform, it means that the distance you have covered is constant for each interval. That if you take for the first 1 hour, you covered 10 kilometers. For the next 1 hour, you covered 10 kilometers. For the next 1 hour, you covered 10 what? Kilometers. So here you are noticing that the distance and the time are constant. That after 1 hour, you have covered the distance of 10 kilometers. That's what we call a uniform motion. And when it comes to uniform motion, the moment you plot the distance against time, you get this straight line. Then when it comes to non-uniform motion means that you are not constant with how you are covering your distance. You'll find that for some part of the journey, you took 1 hour to cover 50 kilometers. Then you find that another 1 hour, you covered only 10 kilometers. So the distance keeps on varying, much as the time interval between is the same. That here for the first 1 hour, the person covered 20. For the next 1 hour, he covered 5. Maybe due to a mechanical problem, maybe because of jam, maybe because of that. Now that kind of motion is what we call non-uniform motion. So you can have uniform motion and we can have non-uniform motion. If I may ask, if you are traveling through jam, is it uniform motion, non-uniform motion? Put in the chat what you think. If you are traveling through jam, is it uniform motion, non-uniform motion? Put into the chat, what do you think? If you are in jam, is it uniform, non-uniform? Okay, perfect. I've seen the answer. People saying it is non-uniform. Yes, that is very, very true. I agree with you. Yes, Dennis. Okay. Yes, non-uniform. Because you can notice that you may find, do you know that you can spend, okay. Okay, let me ask someone. Now whether you can tell us why you have said non-uniform before I tell you my answer. Then after we shall have Sakura come in also. Uh-huh. You can tell us? Oh, I'm not getting her.
Why it's non-uniform motion is because if it were to be in uniform motion, okay, let me just start from non-uniform. In non-uniform motion, you can spend 2 hours in, okay, like for example, you spend 2 hours in traffic jam and your speed is not constant, so it counts as a stop. And then like when you continue moving, if you're to put it on a graph, your speed will not even be in the same, how do I say, the same way it goes is not the same way it looks on the graph. Okay, like it will be bendy, like the diagram you've shown us.
Okay. Okay, good. Yeah. So that is true. Like when you are in jam, you find that these policemen are stopping you. You may find that you for 1 hour you have only covered 5 kilometers. You sit in the car, then after they extend by a small distance, then you wait. So that is what we call non-uniform motion. That the time and the distance you cover keeps on changing, Then we have what we call uniform velocity. Now, like we have said, uniform means constant. Now, whenever you see the word uniform means what? Something that is constant. That after 1 hour, the distance you have covered is the same. Now, when we are talking about velocity, here, the word you need to emphasize is displacement. Now, when we are talking about uniform velocity, it means that the displacement is constant. That is what we call uniform velocity. So uniform velocity, this word is very key. Constant rate of change of displacement. That's what we call uniform velocity. That after given period of time, the displacement you cover is the same. Maybe after 1 hour, you have covered 20 kilometers or 20 meters. So that is constant. Does not change. Yes. So can you write something? Any people finish, you let me know, and then we continue. Okay, people are saying they are finished. Okay. I'm going to ask you in your book to draw for me, to come up with, to draw. It is okay. We are not going to use a graph, but in case you have a graph, I want you to plot for me this. I want you to come here on your graph. Along the y-axis, put displacement. Along the x-axis, put time. Those who have graph books, you can use a graph book and we plot these points. Those who have graph books, use graph books. In case you don't have, improvise. And then we first plot. Okay, let me hope people have come up with something. Hope people have come up with something. So this is what I'm expecting you to have. To plot, this is 0. You say this is 1, 2, and this is 3. Then here you can have, let me say 2, 4, and 6. So 0, 0 is here. 1, 2, 1, 2 is here. 2, 4 is here. And 3, 6 is here. And then you draw a line like that. So this is what we call, we are going to check out whether it is uniform or whether it's not uniform. Now, this is mine. This is my graph. Now, how do you check whether it is uniform or not? Now, in order for you to check whether it is uniform, you have done something called gradient in math. So what you do, you can just come check out from here and here. When you check out, now when we are checking out whether the gradient is the same, you count from here up to here. How many boxes do you have? That here you have 2. Then from here up to here, how many do you have? That you, okay. Now here, we have 2 boxes, but each box here, when you check out, it has, this box here has 1. This one has 2. Then when it comes to this one means that it has 0.5, this one has 1. So when you are finding the gradient, you need to take that into consideration. You take that into consideration. So now to get the gradient, I think you looked at it. You said the change in y out of the change in x. So the change in y here, we have 2 divided by 1, which is equal to 2. Now to check out another area, whether the gradient is the same, so that you say it is uniform, you just come here. And here, please feel free when you are checking, even if you draw a big triangle like this. Let me draw for you one. Let me say I've drawn this one, and I've drawn this. What happens when it comes to the gradient? You get the same. So when you check out here, if I'm to find the gradient here, you are going to find out that from here up to here, you have 2. Then here you have 4. So here you have 4. Then from here up to here, you have 2. So that means your gradient is going to be the change in y, which is 4, this 4 here, divided by 2. And your answer still is going to be 2. So since it is the same, then we can say that we have a uniform motion. So this is what we call the graph of uniform velocity. Because at any point, you are noticing that the gradient is the same. Members, is that fine? Is that okay to everyone about that? So that is how you prove. That's how you prove. Maybe Melissa, you can tell me where you have not obtained. Samsung?
Yes, sir.
Yes, please.
For me, I've not understood well as you are explaining how to prove whether
Have you done
gradient
graduate?
is
Have you
uniform.
done something in graduate in math?
Yes.
So we say that gradient means what? Means is the slope. Means the change in your y divided by the change in x. How your vertical movement and the horizontal movement, how they vary. Now, when you look at our graph here, for you what you do, always we use the right angle triangle. So you can come here. Oh, no, I think maybe for you, you use the formula. We can also use, even if you use that one, for you can say, let me pick a point. This point here is 1 and 2. Which point is here? This point is 2 and 4. So you'll come and say my 1 and 2, then 2 and 4. So this is x1, y1, x2 and y2. So you know your gradient is equal to y2 minus y1 out of x2 minus x1. So when you, hope you remember this.
Yeah.
So here you end up with 2 out of 1, which is equal to 2. Even if you had taken this point here, and this point here was 3 and 6, and maybe for you say, I want to use 3, 6 and 1, 2. You say, now I want to use 1, 2, and 3, and 6. Still you say 6 minus 2 out of 3 minus 1, which gives you 4 out of 2, which is 2. So for whatever 2 points you pick along that line, you get the same answer for the gradient.
Okay, thank you, sir.
Melissa, I don't know whether it is clear now how I got those things. I don't know why you are unable to. Melissa, hope that is okay. What I was trying to show you, how I was drawing them, I was using the triangle approach, the right angle. That if I have a right angle triangle drawn along the line, you note that for this axis here, for every 2 boxes, you have 1 second. That means that from here up to here, since these are 2 boxes, this is 1 second. However, when it comes to this vertical one, you note that for any 2 boxes, you have 2 meters covered. So here you have 2. So your slope, this slope here is given by the 2 divided by 1, which is 2. That's what I was trying to explain. Okay, hope now members we are fine. So you need to know these graphs of uniform velocity. Okay. Now, for non-uniform velocity, like I showed you on the graph, for it you'll find that the graph is not straight. You'll find that the interval is not constant, or it's not the same. So that one you will check it out for what we call non-uniform velocity. You'll find that at one point you get the gradient of 5. Another time you get a gradient that is a bit different. So for non-uniform velocity, in case you are sketching, let me just show you roughly here, is that you'll find that here, find something like this. Here, when you try to find a gradient, you get something different. Here, it is different. Here, it is different. So it's not constant. That means that the velocity changes over time. And this one always happens whenever you are traveling. You'll find that the velocity keeps on what? Changing, depending on where you travel. I think the only person in the country that have not, I don't know, but at least for him, always moves at the same speed is, I think, the president, because they always clear the road when he's traveling, and you see the vehicles traveling at this almost the same speed. So that one you can say that it is uniform. But for you people, whenever you are traveling, you have stopped here, you continue, you stop, you continue. So that is non-uniform. Okay, can we summarize the difference between speed and then velocity? Then we are going to look at some examples. So I'm looking through the chat whether people have finished. Okay, when we have more to, we shall move on and look at how we make the calculations. Okay, okay. Have different types of velocities, and this is where I want you now to pay attention. Now, when we talk about velocity, there is what we call an initial velocity. Whenever you are starting your motion, take an example, you are coming from home going to school. When you are starting your motion, there is some velocity or some speed you possess. Many times when you are starting the motion, when you have not started the timing, you'll find that your speed is 0. What do you need to learn is that when we talk about initial velocity, that is the velocity at which you are possessing when they start timing. Not all the time you'll have 0 as your initial velocity, but the velocity at which they start timing is what you call the initial velocity, or what you start with. However, whenever a body is starting from rest, then it means that the initial velocity is going to be 0. If a body is stationary means that the body is not moving, it is static in one place, then it means that its initial velocity is also 0. What do we use? Now, you'll take note that whenever you find a u, these smaller u's, smaller u is going to be standing for what we call initial velocity. So the formulas we are going to be dealing with, the moment you find smaller u stands for initial velocity. Okay, can you first write and then write something and then we start? We'll go to another thing. Yeah, so we are going to look at the different things. I don't know whether Romans, we're on the same page. Okay, Romans. Yes, Didi.
Teacher, I have a question.
Yes.
If you say that the initial velocity starts when is the velocity with which the body starts its motion, and then you told us that if a body is at rest, the initial volume velocity is 0. I thought for a body, like its velocity has to its velocity starts when like the body is at rest. So then if it starts moving, then the velocity comes about that, but the beginning part for the body it has to be at rest.
No, not all the time. Not all the time, but what you are saying is correct. If like you are starting, this is your car and you are starting to start the journey. your speed like keeps on increasing. That is okay. But also there are times, there are questions you are going to meet. Let me say, are you seeing this? Let me use a
Yes.
graph. You are going to, okay, this graph is ugly. You are going to find that there are some times whereby someone is not starting from zero. If you look at this graph here, when you look at this graph, someone may not necessarily start from zero. So this person is not starting from zero. He's starting with some speed. Because sometimes when you are moving, you may want to just time a given part. Let me say, I don't know that these people let me say you are in a rally. Someone may want that they want to start timing you when you have reached a given point. So now if you are already moving and someone wants to time you and find out the speed you are traveling at, then that means that the velocity you are starting with when the person is timing is not zero. I don't know that you're getting the difference.
Yes.
Eh,
Thank you, teacher.
okay. But they will specify that the person is starting from rest. The moment they say starting from rest, then there it is automatically zero. You are just starting, you have not been moving. So if someone has not been moving, then it means that it is zero. But if someone has already been in motion, then it means that there is some velocity he has started with when he was traveling. Then we have the second one we call the final velocity. The final velocity is the velocity you end your journey with. Take an example, you have traveled and went. Take an example, like I showed you, I think. I was showing you about this skater. When I was showing you this skater here. Now, when you look at this skater, let me use here. When you look at our speed, at this point, you are not seeing that it is zero. But when I release him, at this point it is zero. Like if you look here, you notice that it is what? Zero. But the moment I start him to move, you will find out, let me put it in slow motion. When I start moving, now here we shall say that the initial velocity, since it's starting from rest, we shall say that u is equal to zero. Then when I release him to start moving, and it starts like that, his velocity increases. So when the velocity increases, oh, you go. Are you seeing where he has ended? Now, this side where he has ended, this velocity he has finished his journey with, when you check here, it is 10.8. And now that's what you call V, and that's what you call 10.8. So this is what you call the final velocity when you have finished the journey. I don't know if the members are getting the difference. U is what you start with. However, I want also to show you that, however, if, let me say, I get this gentleman here and I put him somewhere here, and then I start him off like that. Now, if this gentleman has been already in motion, and this is the speed he was at, then this one can as well be our U. And what he finishes with is what we call the final velocity. So you need to know that initial velocity is for someone who is starting from the rest. But if someone has already been in motion, then it means that that person, things are totally different. Okay, let me hope you have got the difference between what you call final velocity and what you call initial velocity. Okay, so are we there? Are we on the same page? Are we on the same page? Are we good to continue? Okay. Yes, solids. Okay, so we are going to continue and then look at that. Now, there are two things I want you to take note of. One, what we call the average velocity. Average velocity, average, like average, let me use your max. Let me say, uh, let me say, which name can I use? Let me say, in math, you get in maybe assessment 1 you got 90. In assessment 2 you get 98. Your average means that add the initial marks you got plus the final divide by 2, or you can say that beginning of term you had a 90, end of term you had a 92. So your average means that you the 90 plus the 92 divide by 2. So when we talk about average velocity, you get the final velocity, the velocity you have ended the journey with, plus what you started with, divide by 2. That's what we call the average velocity. Then we have what we call acceleration. Now, acceleration means how is that velocity changing with time? That is what we call acceleration. So acceleration, we represent it using a small letter a. So whenever you find small a stands for acceleration. Now, equals to final velocity. Final velocity is the velocity you have ended with, minus what you started with, divide by the time. Now, these formula members here, it's going to be very key in physics. You are going to utilize it a lot whenever you are using it. And what are the SI units? SI units means that velocity, we give it in terms of meters per second. Then divide by time, which is also second. So from your mathematics, you remember this is m per second times per second per -1. From your mathematics, you learned something like a power 2 is the same as a power -2. So when you have 1 out of s is the same as s power -1. Then from indices, numbers of the same bases, you add the powers. So you end up with m s per -2. So the SI units for accelerations are meters per second squared. Or they write it like this or like this. But this formula is going to be very important. So may I invite you now to write something? But in case you have a question, feel free to ask. When you finish, you let me know. Okay, from the chat, I'm seeing quite a number. Okay, I'm going to Okay. So I repeat on acceleration. Acceleration means how is velocity changing? How is velocity changing? Now, acceleration is obtained by, in case this is my graph, acceleration, we are looking at the velocity and the time. Now, acceleration, you may look at it, okay, acceleration is how is this particular thing changing with time? Now, acceleration, like when you hear the word change, change means that it's like a transformation. Like when they say that someone changed, it means that initially he was someone. Then afterwards he changed. So a change means that there is some kind of transformation from who you were to a new person. So acceleration means that what was this person initially and now what he is, there is a difference. So acceleration is the difference in the velocity that you have ended with and what you started with, but with time. So that's what we are saying, that what did you start with, which we are calling V? What did you end with? Minus what you started with, divided by the time. So we are asking that after what given period of time are you changing? That's what we call acceleration. Okay. In other words, you are looking at how quickly does something speed up? How quickly does something slow down? How quickly does something change direction? So that is acceleration. And many times, like I will give you an example. Whenever you are those people who have bikes, you'll find that when you are on a hilly area, let me say you're going down a slope, you will hold the brakes. So your speed changes, like once you get the brakes, you'll find that your speed keeps on changing, becoming very small. That's what now we call decelerating. Decelerating means that your velocity is reducing. When you are increasing your velocity, it means you are accelerating. Okay. So, members, are we good to continue to another screen? Speeding up is acceleration. Slowing down is what we call deceleration. Okay. So we are going to, so when you look here, I'm showing you some pictures. When you look at the first picture here, when you look at this is what we call accelerating. The person is speeding up. At first, he started slowly. He went on increasing. That's what you call accelerating. That you started with small, slowly, and then you took off completely. Then when you look at the second picture, this person was traveling at a very high speed, and then he went on slowing down until when he came to rest. So that's what we call accelerating, and decelerating is what called the slowing of the speed. So I'm going to, before we go here, I want to display here, and I want people to tell me I'm displaying this. I'm going to use this. I'm going to put different points, and you're going to tell me accelerating means you are speeding up. Decelerating means you are slowing down. So you're going to tell me which points on this graph are going to be representing. Is this gentleman? You are going to look at this one here. You look at the speed here. When the speed is increasing, we say is accelerating. When the speed is reducing, that's what we call decelerating. When it is increasing, that's what we call accelerating. I don't know whether members are getting the difference. We have two things. One is what we call acceleration. That one, you are going to type in the chat the A, and then deceleration, the gentleman is slowing down, you type D. So I'm going to put this gentleman here, and I'm going to put him in a slow motion. So you observe, and then before you look at the speed here, you check here the speed. When you see it going up, then it means that the person is speeding up. When you see it coming down, it means the person is decelerating. So I'm going to put some points, and then someone will may tell us for you what you have observed. This is B, this is C, and this is D. So I'm starting my motion. So someone can raise up the hand, and you tell us, that movement the gentleman has moved. Where was he accelerating, decelerating, like that? Yes, Daniela. Yes, Daniela.
Yes, Daniela. Part A was accelerating.
Mm-hmm.
Part B was decelerating.
Mm-hmm.
Part C was accelerating,
Mm-hmm.
and then was decelerating.
Mm.
Yeah.
Okay, good. Thank you, Daniela. Kinomoto.
Yeah, she's right. At A, he was accelerating.
Mm-hmm.
B, he started decelerating a bit. C,
Okay.
he was
Kinomoto, can you now
he
describe for
accelerated
us
and
this one? Are you saying I'm releasing a new one? Where he's coming from?
yeah.
So your title may be a comparative background showing Uganda's imports and exports with the selected countries. Okay?
Okay. Teacher, may I ask a question?
Please do.
You had said you could also draw a pie chart. So
Yes.
then would you end up drawing two pie charts?
Yes. Basically, yes.
Chinomoto, you can describe that? Oh, Chinomoto, are you able to unmute?
Yeah. Yeah.
Okay.
So from where he was coming from D, he was accelerating because he was going through a slope. Then from C, he started decelerating because he was going through the loop. And when he was coming from up, it started to become like a slope from B. So he accelerated again. And when he was going upwards to A, he started decelerating again because he needed more energy to go up that way.
Okay, thank you. Thank you. Thank you, Shinamoto. So I come back here. Now we are going to try out some few numbers. We are going to try out some few numbers here. Now, always the moment you read the question, you summarize. You summarize. So we have a car starts from rest. Now, the moment you see the word starting from rest, like when you are starting from the rest, it means that initially your speed is 0. So the moment you see that one, you take note that my u is equal to 0. Chinamoto, question?
No.
Okay, but leave your thing. Don't mute.
Okay.
Then, Chinomoto, what have we used for final velocity? Which letter do we use?
We use the V.
V. Very good. So V stands for your velocity. And always look at the units. They will guide you that those are meters per second. In 30 seconds. In 30 seconds, what is that? Chinomoto, what does that represent?
The 30 seconds. The time.
The time, which is 30 seconds. So the question is asking you, what is the acceleration? Then you come and say acceleration. Chinomoto, what is the formula?
V minus U out of T.
Out of T. Very good. Can you substitute?
60 meters per second. Sorry. Yeah, 60 meters per second minus 0 meters per second out of 30 seconds. Then, like 60 minus 0 is equal to 60 out of 30. Then that's 20. That's 2, sorry. That's 2.
Units?
Meters.
Per second?
Per second, yeah.
Squared.
Yeah.
Okay. Thank you, Chinomoto. Okay, yeah. So that's how you do it. First summarize what you have from the question, and then from there you move on. Okay, so first write that, and then we look at something. Okay, Jeffrey, okay, Miss Jeffrey, thank you. Okay, so we are going to continue. Let me hope members are finished, right? Let me hope. Okay, so I'm going to display another one. So can we have someone raise up the hand? Okay, Nancy and Noella, can I unmute? First summarize for us.
By spirit. Okay. The initial velocity is 2 meters per second.
Okay. Why? Okay.
The final velocity is 9 meters per second. Go ahead.
Yes, go on.
The time is 1 second. So determine Morgan's acceleration. So acceleration is equals to final velocity minus initial velocity. So that will be v minus u out of t. 9 minus 2 out of 7. So it's 1 meter per 1 meter per second.
Okay, it is 1 meter per second squared. Okay, thank you, Nisa and Noella. Yes, so that's how you get the thing. So this is what I was trying to show you, that not all times
Per
that your initial
second.
velocity will be 0. Because here they told that starts running with a velocity of 2 meters. That means that the time they started timing his journey, his velocity was at 2 meters per second. That is the meaning. Yes, Venus and Laris and Samsung. Yes, Laris. Hope everything is fine.
Sure. I was asking, can you explain how the units become squared?
Oh, like you are you still on?
Yes.
Do you remember this law in mathematics? Okay, let me start with this. 1 out of AM in mathematics, how did your teacher tell you is equal to? Did he write something like that?
Yes.
What about when I have 1 out of S? Write it for me in this format. What shall we write? Let me.
Is it
Okay.
S? Let me see.
Like this. Okay. What you
Yes.
have to know is that is like I've told you that acceleration is like velocity out of time. But velocity is meters out of seconds. Then out of this time, which is seconds, the units. So what happens is that when I have this mathematical is the same as in meters out of second divided by s, which will give you m out of s times 1 out of s. So what do you end up with? You end up with m out of s squared. So mathematically, this is what we write as meters per second squared or meters per second squared. So that's how those seconds come squared.
Okay. Thank you, teacher.
Okay. 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 Yes, Venus? Okay, I think let me give you one more number because I'm seeing our time is up. I give you one more number. Can you just take a screenshot of this? Take a screenshot of this. Now let me first give you some exercise you're going to try out. Take a screenshot. Now when they tell you deceleration, here your answer will be negative. When you make your calculation and you get negative, it shows that it is decelerating. Okay, let me hope people have taken a screenshot. Yes, Ellie?
Excuse me, teacher. I am unable to fully view the screen.
You are saying?
I'm unable to fully view the screen.
Hey. Okay, I will share the work in the group, but someone can share a picture. in the chat. Hey, someone can share a picture. Okay, I want to see whether I have another number for you people. Okay, this is the second number. Now, what do you need to know? Here, we are testing you. Here, when you are doing this, make sure you convert this to meters per second. Because time is in seconds, so convert this speed to meters per second, such that the units resemble. Whenever you are dealing with kilometers per hour, work with hours. When you are dealing with the Yes, when you are dealing with the kilometers per hour, your time should be in hours. If you are dealing in meters per second, then your time should be in seconds. So be mindful of that. Okay. Okay, let me see whether I have another one for you people. Okay, so members, we shall start from there. The next time we shall meet. I had a quiz, but the quiz we shall do it next time. We shall do it next time. Yes, Eileen?
Teacher, I was like saying, can't we like change unit time,
The
like when
units?
yeah, my answer
Or
either
like the answer, are you saying that they told that you write it in meters per second squared? Your answers
yes teacher.
here. So the best is better you work it out from the other side when you have already converted.
Okay, teacher.
Okay. Then yes, M Copper.
Teacher, what I wanted to ask, right? The previous speaker has been talking about that. You mean that we have to change we shall have to change the 108 kilometers to meter per second.
Perfect. Perfect.
Yes. Hey.
Yes, you have to change
Okay.
it. So you convert
Mm.
these kilometers to meters, convert the hours to seconds.
Okay. Thank you,
Okay.
teacher.
Okay. Okay.
Mm.
Okay. So, oh, the quiz we shall do it next time. We shall do it next time. We shall do it next time. Okay. Have a good evening. Have a good evening. Rahim, what are you saying, Rahim?
So teacher was asking,
Hmm.
teacher, are we going to get compensation for the lost lessons?
Oh, we shall. We shall. We shall have lessons next week.
Okay, teacher. Bombo.
Okay.
Bombo.
Okay. So let's end here. We shall start from here when we meet again. Have a